All right, sketching the graph of a tangent or cotangent function. First of all, you might want to know what the graph of a tangent or a cotangent function looks like. If I have my tangent function, normal graph of a tangent function has a period of pi. Sine and cosine had a period of 2 pi. Tangent and cotangent will have a period of pi. Tangent, the middle is going to be right here at 0 at negative pi over 2, and at positive pi over 2, you're going to have your asymptotes. For your normal tangent curve, you are going to start on the negative, end on the positive, and your graph is going to look something sort of like that. Cotangent curve. Cotangent curve looks a whole lot like the tangent curve. It's just pushed over and then it starts in the positive and ends in the negative. So for my cotangent curve, my period again is pi, so it's going to go from 0 to pi. My asymptote's going to be right on 0, although my line didn't want to draw there. Halfway between that, so at pi over 2, it's going to be at 0. It's going to start on the positive, end on the negative, and so my graph is going to look something sort of like that. So if I'm going to graph my tangent curve, I'm going to start with my main points of my tangent graph. I have negative pi over 2. Halfway between here and here would be negative pi over 4, 0, positive pi over 4, and then positive pi over 2. At negative pi over 2 and positive pi over 2, you're going to have your asymptotes. At 0, you're going to be at 0. At negative pi over 4, you're going to go down the amplitude normally. And at positive pi over 4, you would go up your amplitude normally. So, just like we did when we graphed the sine and the cosine curves, we're going to take our shifts, set them equal to our normal x values, and solve. So I'm going to say x minus pi over 2 is going to equal negative pi over 2, going to equal negative pi over 4, going to equal 0, going to equal pi over 4, and going to equal pi over 2. So if I'm going to solve those, I have to add my pi over 2 to each of those x values. So if I add my pi over 2, negative pi over 2 plus pi over 2 is going to give me 0. Negative pi over 4 plus pi over 2. So this would be 2 pi over 4. Negative 1 plus 2 is going to give me a positive pi over 4. 0 plus pi over 2 is pi over 2. Pi over 4 plus pi over 2, again, this would be 2 pi over 4. So 1 plus 2 is going to give me 3 pi over 4. And pi over 2 plus pi over 2 is 2 pi over 2, which is just pi. So again, thinking of your fractions, negative 1/2, positive 1/2, just ignore the pi, and so forth. First one's going to be my asymptote. The next one, I'm going to take negative 1 times my amplitude of 2, so negative 2. The middle one's going to be at 0. Then I'm going to have positive 1 times my amplitude of 2, and the end's going to be my asymptote. So my asymptotes are at 0 and at pi. At pi over 2, halfway between my two lines, I'm crossing the x-axis. And then at pi over 4, I'd be at negative 2. At 3 pi over 4, I'm going to be at positive 2. And my tangent graph is going to look something sort of like that. Number 8, we are going to do a cotangent graph. So thinking about my normal values for cotangent, cotangent starts at 0 and ends at pi, has a period of pi. Halfway between pi over 2 is where I have my 0. So this would be pi over 4. This would be 3 pi over 4. And so I have an asymptote here, asymptote at the end. With my cotangent curve, normally I start on the positive end and end in the negative end. So those would be my normal standard values for cotangent. So cotangent of x plus pi over 3. So x plus pi over 3, we want to set equal to 0, equal to pi over 4, equal to pi over 2, equal to 3 pi over 4, and equal to pi. And then we want to solve each of those. So we are going to subtract our pi over 3 in order to solve each of those. So subtract our pi over 3, pi over 3, almost can read that. So 0 minus pi over 3 would be negative pi over 3. 4 pi over 3 minus pi over 3, I'm going to put them over 12. 4 goes into 12 3 times, so 3 pi over 12. 3 goes into 12 4 times. 3 minus 4 would give me negative pi over 12. Here I'm doing 2/3, so I've got to put them over 6. 2 goes into 6 3 times, so 3 pi. 3 goes into 6 2 times, so 2 pi. 3 pi minus 2 pi is going to be 1 pi over 6 then. Here again we've got to do 12s. 4 goes into 12, 3 times 3 is 9. 3 goes into 12 4 times. 9 minus 4 gives me 5 pi over 12. And then we've got pi minus 1/3. 1 minus 1/3 would be 2/3, so 2 pi over 3. First one's going to be an asymptote. Last one's going to be an asymptote. Middle one's going to be 0. For my cotangent curve, I'm going to take 1 times my amplitude, which is 1 in this case, gives me 1. Negative 1 times my amplitude, going to give me negative 1 there. So my asymptotes at negative pi over 3 and 2 pi over 3. Well, you'll notice I don't have any over 3s. I've got to figure out what units I'm in. In this case, if I count from 0 to pi, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So each of my marks is pi over 12. Negative pi over 3 would be negative 4 pi over 12. So 1, 2, 3, 4 marks. That's where my negative pi over 3 is, so I can put my asymptote. Positive 2 pi over 3, if I put it over 12, would be 8 pi over 12. So positive 8. 1, 2, 3, 4, 5, 6, 7, 8. That's where my asymptote's going to be. Pi over 6 would be 2 pi over 12. So at 2 pi over 12, I should be at 0, halfway between each of my asymptotes. Looks like that's halfway between each of my asymptotes. At negative pi over 12, which is just back 1 mark, I'm up to 1. And at 5 pi, 1, 2, 3, 4, 5 over 12, I'm down to negative 1. And so my cotangent curve in this case looks something sort of like that. I'm not very good with my curve, but when you hit the graph button on Alex, it'll draw it nicer than I can draw. It's going to look something sort of like that. So here are my starting values for cotangent. We had the other ones for tangent, and we're going to do tangent again. So number 9, we are graphing y equals the tangent of x plus pi over 6. Normal tangent graph starts at negative pi over 2, ends at positive pi over 2. Has a period of 1 pi. Halfway between is going to be the 0. 0, 0 is going to be the middle of my graph. Negative pi over 4, positive pi over 4. So we said 0, 0 is the middle. That at the beginning and the end we're having our asymptotes, just like on the cotangent curve. With the tangent curve, normally you start in the negative direction, end in the positive direction. So x plus pi over 6 is going to equal each of my starting x values. negative pi over 2, negative pi over 4, 0, pi over 4, and pi over 2. If I'm going to solve, I'm going to subtract pi over 6 from each of my values. And then I'm going to do my adding and subtracting with my fractions. Ignore that the pi is there. Think of it as 1. A negative 1/2 minus 1/6. I'd have to have twelfths. 2 goes into 12 6 times, so minus 6. 6 goes into 6, or 6 goes into 12 2 times, so minus 2. Negative 6 minus 2 would give me negative 8/12 pi. I can simplify my fraction because I can divide by 4, so negative 2 pi over 3. On the other one, again, I would have a common denominator of 12. 4 goes into 12 3 times. 6 goes into 12 2 times, so I'm going to get negative 5 pi over 12. Here I'm just going to have negative pi over 6. Here again I've got, here I've got a positive pi over 4. I thought I had the same thing up there, but that had a negative. So again, I'm going to put it over 12. 4 goes into 12 3 times. 6 goes into 12 2 times. 3 minus 2 is a positive 1 pi over 12. And then here, if I go over 12, 2 goes into 12 6 times. 6 goes into 12 2 times. I get 4 pi over 12, which would reduce down to pi over 3. So we know that at the beginning we're going to have our asymptote. At the end we're going to have our asymptote. In the middle we have 0. Here we're going to take negative 1 times our amplitude, which is 1, so negative 1. And then 1 times our amplitude is 1. So asymptote is at negative 2 pi over 3. Again, we don't have them over 3. And if I count, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It doesn't quite fit on there, but it is twelfths that it is in. It's just hard to see. So negative 8. 1, 2, 3, 4, 5, 6, 7, 8. Negative 8 pi over 12 is going to be where my first asymptote is. That's what we had here before I simplified. If you think about this, from 0 to pi over 4, which is 1/4, there is 1, 2, 3. So if I divide that by 3, 1/4 times 1/3 means each of those marks are 1/12 of my way. Negative 5 pi over 12, 1, 2, 3, 4, 5. I'm going to be at negative 1. Pi over 6, or negative pi over 6 would be negative 2. That's where I'm at 0. Positive pi over 12, I'm at positive 1. And then at pi over 3, which would be 4 pi, 1, 2, 3, 4 over 12, I have my other asymptote. So my tangent curve is going to look something sort of like that. And again, if you're not sure where the marks are, you can always use the plot point tool for the dots. You can actually use the plot point tool here and do something like negative 2 pi over 3 and 0. It would put an X there so that you know that you can erase the X and put your asymptote on top. So if you're not exactly sure where that line is on Alex, plot it as a point to get a dot on your graph. Then you'll know where that line is.